Alright guys, so in our last video, we talked about convergence of alternating series. So today we're going to talk about two different types of convergence. So these are just some special terms that talk about how an alternating series can actually converge. So the first one of these is what's called absolute convergence. Okay. And absolute might remind you of absolute value, which is exactly what's going on here. So we say that a series A sub n is absolutely convergent. Absolutely convergent. If that series converges, and if you take the absolute value of each term, if that also converges. So absolutely convergent means that the absolute value also converges. So what's happening here is when you take the absolute value just kind of removes the alternating part. Because all the alternating part does is give you a plus or a minus sign, right? So if you take the absolute value of, negative 1 to the n times 3n, this is just a plus or minus 1. So the absolute value of that is just 3 to the n. It just gets rid of it. Okay, so that's the first term. So we are also going to say, and the other term is, we say a series, A sub n, is conditionally convergent. So conditionally convergent. If you take this series A sub n and that converges, but when you take the absolute value, it diverges. So basically, if you go ahead and you remove that alternating part, and you get a divergent series, that's something that's conditionally convergent. It's basically convergent, but that convergence is conditional based on that alternating part. So let's take a look at basically only converges because of the negative 1 to the n or negative 1 to n plus 1 or whatever. So let's look at some example problems that you'll see these. So they will love to ask you questions that look like this. Does this series diverge? Does it converge absolutely? Or converge conditionally? And honestly, these terms really only make sense if you're talking about a series with an alternating term, a negative 1 to the n. So let's suppose we look at the alternating harmonic series, negative 1 to the n plus 1 over n. Basically, the way you're going to answer the question is you're going to consider two series. So we're going to ask ourselves, does the original series converge? So just the series that I've given you right here, does this converge? And then if I take the absolute value, is that one converging as well? So we check the original series, then we take the absolute value of each term and consider that series. And we just ask, does this series converge, does this series converge? Okay, so let's look at the original series. So the original series here, this is an alternating series. The terms are decreasing, of course. So because this series alternates, we're going to take the limit as n goes to infinity of the rest of it, which is 0. So because this alternates, the absolute value of the terms decrease, and the limit is equal to 0, so we know that this one converges. So it's not going to be divergent, right? It's either going to converge absolutely or conditionally. So now we're going to consider the absolute value term. Okay, so if we take the absolute value of A sub n, all that does again is when you take the absolute value, it just removes the alternating part, the negative 1 to the n. And this is because, if you take, the absolute value of negative 1 to the n times the absolute value of 1 over n, you could do the absolute value negative 1 to the n times the absolute value 1 over n. Well, this is positive, so this is just 1 over n, and this just goes away. It's just 1. So that's what happens. That's where that comes from. That's why taking the absolute value just removes the negative 1 to the n. So when you do that, you're looking at the series 1 over n. And once you have that, then you could just use any of our other tests. So we can use a p-series or a limit comparison test or something. So 1 over n, this is the harmonic series. So this is an example of something which diverges. Okay, so to help us answer the question, and I kind of wrote a lot of explaining, we'll go faster through these, but to help us answer the question, the original series converges. But when we take the absolute value, that series diverges. So this is the definition of conditional convergence. So this is an example of that. The series conditionally converges. Let's look at one more. So suppose in our next example, we take the sum, let's say 1 to infinity of -1, let's say, this was okay. So let's say -1 to the n times 1 divided by an n to the 4th power. Okay, so when you take a look at this, like let's say this series is an alternating series. So because the series alternates, so we take the limit of what's n goes to infinity of the rest of it, which of course is 0. Okay, so because it alternates, the limit is 0, the terms decrease, so the series converges. So now our next question again is it absolute or is it conditional? Because that's what these questions are kind of asking. And they'll be very clear when they're talking about conditional or absolute convergence. All the question will always mention it. So we're going to consider taking what happens when we take the absolute value. So we're just consider the series of 1 over n to the 4. Okay, well once we look at this series and we ask ourselves, does it converge? Again, it's not just a limit. You actually have to consider whether the series converges. You look at it and say, hey, okay, this is a p series. My p is equal to 4. So this series also converges. So even if we take the absolute value, it still converges. So when we looked at the absolute value base of n, we still got a series that converges. So this is absolute convergence. If the absolute value converges, the whole thing converges absolutely. Okay, so that's absolute versus conditional convergence. Hope that helps. Bring some questions to class, and thanks for watching.